Hello, this video will cover atomic properties and how to draw a Bohr model. All right, what is a Bohr model? Well, it's simply a way to represent an atom that's going to give us a clue to whether and how an atom might react with other atoms. So let's just dive right in and draw our very first atom. And we are going to start with one of our very favorite atoms, and the one that arguably is the most important to biology, and that would be carbon. Okay, so chemical symbol C. Carbon has an atomic number of 6 if we look on the periodic table, and atomic number means the number of protons. That is the definition. I've just drawn a P plus to refer to protons because protons are the positively charged particles in the atom. Okay, this is also going to mean at a neutral charge it has 6 electrons, okay? And then the third subatomic particle, the neutrons, it will have either 6 or 7 or 8 depending on what isotope we're talking about. All right, but we're not going to really worry about the neutrons right now. What we care about the most are the electrons. Okay, so let's draw a Bohr model, and we're always going to draw Bohr models from the inside out. We will start with the atomic nucleus. And I'm going to write a C in here so we know that this is a carbon atom. And in this atomic nucleus, we have the protons and the neutrons. The electrons are going to be outside the atomic nucleus. And this is where the Bohr model is arguably wrong, because we're going to draw the electrons as if they're planets orbiting the sun, which is not really the case. If you take chemistry or physics, you're going to learn about, electron clouds and orbitals, and that's just more detail than we actually need in biology. So we are going to draw shells, okay? So here is our first shell, our very first electron shell, and in that shell, we are going to place 2 electrons. All right, this is the max capacity of the first electron shell. All right, and then we're going to draw a second shell. The maximum capacity of this shell is 8, but carbon has only 6 electrons, and we've already placed 2. So that leaves us 4 to put in that second electron shell. The outer electron shell, sometimes called the valence shell. And this brings us to a fundamental property of atoms. All right, so atoms are stable when their outer shell is full. Okay, so we're looking at carbon here. The outer shell can hold 8 electrons, but it only has 4. So is carbon happy? Is it stable in this configuration? Absolutely not. Carbon is not stable. It wants to react with other atoms in order to fill out that outer shell. All right, let's look at our other 3 elements that are super important for life. Okay, next up is nitrogen. Nitrogen has an atomic number of 7, so that means, by definition, it has 7 protons. Always 7 protons. Every atom of nitrogen has 7 protons. Now, before we react with anything at a neutral charge, we're also going to have 7 electrons, so 7 negatively charged electrons, and then we'll probably have 7 neutrons. That would be the most common isotope of nitrogen. All right, so let's draw the Bohr model. Okay, once more, we're going to start and move from the inside out. So here is our atomic nucleus of nitrogen, once again where the protons and neutrons are. And then we're going to start drawing our shells and placing our electrons in those shells. So once again, first shell, it can hold up to 2 electrons. Second shell can hold up to 8, but we only have 7 and we've placed 2. So that leaves us 5 to place in the second shell. Okay, there's our Bohr model of nitrogen. Is nitrogen happy and stable? Nope. It would like to have 8, but it only has 5 in that outer shell. All right, moving on to a personal favorite element of mine, oxygen. Okay, so chemical symbol O. Oxygen has an atomic number of 8, which means 8 protons, 8 electrons, and 8 neutrons. Okay. So once again, here's our atomic nucleus with an O for oxygen inside. First electron shell, we're going to draw 1, 2 electrons. That's all it can hold. And that leaves us 8 minus 6, so 6 electrons in that second shell. Okay, so there's oxygen. And then finally, our 4th element that is the most common and important for life, We have hydrogen. Hydrogen has an atomic number of 1, which means just one proton. Okay, so if we're neutrally charged, we'll also have one electron. And usually hydrogen doesn't have any neutrons at all. There are a couple of rare isotopes that do have 1 or 2 neutrons, but 0 is going to be the standard. Okay, so once again, here's our atomic nucleus. That's where the proton, the single proton is. And then our first shell, which can hold up to 2, but of course it only has 1 because hydrogen just has 1 electron. Okay, so looking at all 4 of these, none of them have a full shell, okay, which means they're going to be reactive with other atoms. All right, and we can also say a little bit about how many potential bonds they can form. The bonds we care the most about are covalent bonds. And covalent bonds is where atoms share electrons, okay? And they share them such that their outer shell acts as if it's full. So if we look at hydrogen, it has 1 electron in its outer and only shell, and it would like to have 2 to be full. So how many are we missing? Okay, we're missing 1. How about oxygen? That outer shell, again, that's the only one we care about for reactivity, has 6 electrons, but there's a max capacity of 8, so we are missing 2. Nitrogen, we have 5 electrons in the outer shell, but the outer shell has a max capacity of 8, so we are missing 3. And finally, carbon. The secret sauce to all biological macromolecules has 4 electrons in the outer shell, but it needs 8, so it is missing 4. And this 1, 2, 3, 4 is how many covalent bonds each of these can form. We'll talk about covalent bonds a little more next time.